Here, let's make a connection with our function notation and a graph. If we have an f of a equals b, then we have the point AB that lies on the graph of f. Conversely, if we have a point AB lying on the graph, then f of a equals b. So we can graph these points by finding a and f of a. So let's use the graph of f to evaluate the given expressions here. If I have f of 0 or f of 2, what are they talking about here? Well, f of 0 means, well, they've replaced x with 0. So they're saying, oh, well, this is the point on that graph where x equals 0. So that's the point 0, 3, isn't it? So if we have the point 0, 3, then f of 0 equals 3. Now let's find f of 2. f of 2 would be over here. So this is where x is 2. It's the point 2, negative 1. So that means that f of 2 is negative 1. On the next one, let's find f of negative 2 and f of 1. So we're looking here at f of negative 2. We're finding x of negative 2. We happen to be right on the graph, right there. So that's the point negative 2, 0. So f of negative 2 must equal 0. Now f of 1, we make x 1, and f of 1 is up here. So on the function we have 1, 2, so f of 1 equals 2. Now let's sketch a graph of f here, and you'll notice it's f of x equals 1/2 x minus 2. That's the same as y equals 1/2 x minus 2. So really, it's just the graph of a line. So we can look at this as y equals mx plus b form. This would be our slope, and this is our b, our y-intercept. So we have this y-intercept of negative 2. And to get to the next point, we use our slope of a rise 1 and run positive 2. So rise 1, run positive 2. We can do that as many times as we like to make it clear where our line is going. And then we just need to draw our line with arrows through it at the ends to show that it keeps going on both of those directions forever. So that's a sketch of f. Let's say we want to sketch this graph. That's something that you may not be familiar with, so let's say that we make a t-table of values. Now, a lot of times it's good to make a t-table of values that start with some negative numbers, 0, and go through some positive numbers to get a nice array of numbers to try in that function, especially if you don't know what that function looks like at all. So if we try this, and I put in a negative 3, negative 3 plus 1 is negative 2, and the square root of negative 2 is not going to be real. So apparently we can't use that value. If we put in a negative 2 plus 1 is negative 1, and then we're taking the square root of a negative number again. So we can't use negative 2. Let's try negative 1. Negative 1 plus 1 is 0, and the square root of 0 is fine. It's just 0. If we put in 0, 0 plus 1 is 1, and the square root of 1 is 1. We put in a 1, 1 plus 1 is 2, and the square root of 2, if you'd like to, you can put this in on your calculator. Square root is underneath that x squared button, so we have to use that second button to get to the square root. Square root of 2, and hit enter. We get about 1.4. We can just round this to 1 decimal place because 1 decimal place is about as accurate as we can graph on a scale that is this small. So we'll go about 1.4. Okay, approximately 1.4. If we put in a 2, 2 plus 1 is 3, and so then we're taking the square root of 3, and we get about 1.7. And we put in a 3, 3 plus 1 is 4, and the square root of 4 is, of course, 2. Let's go ahead and graph those points. So we have a negative 1, 0. We have a 0, 1. We have 1, 1.4, 2, 1.7, and 3, 2. So you'll notice this is not a straight line. It's curving a little bit there. So, what's going on? Maybe if we pick another number further out. We knew we didn't have any luck going this way, but let's say that we pick a number out here. I'm going to pick an 8 just because if I put 8 in there, 8 plus 1 is 9, square root of 9 is 3. We get a whole number out. So let's see, if I go 8, then I get 3. So we see that this is going up pretty fast, and then all of a sudden it's leveling out really slow. So it's doing this type of thing. Now I could keep going if I wanted to keep picking numbers this way, couldn't I? So what happens is that this levels out. It keeps going up, but very slowly. And on this side, we know that we didn't have any luck with numbers to the left of negative 1, so we have to stop right there. All of your square root graphs are going to have that general shape. Let's use the table to evaluate the given expressions here. So we have f of 0 and f of 2. All we're doing is saying that, well, instead of saying f of x, they're telling us that x is 0. So when x is 0, what is f of x? 5.5. So when x is 0, f of x is 5.5, we have the point 0, 5.5. How about f of 2? If I have f of 2, then it's telling me the x is 2, and the f of x when x is 2 is 3.7. I have the point 2, 3.7. You can see that right in the table. Cost of driving. In 2010, the average cost of driving a new car in the United States was about 50 cents per mile. Symbolically, graphically, and numerically represent a function f that computes the cost in dollars of driving x miles. For the numerical representation, or a table, let x equal 10, 20, 30, all the way up to 70. So increments of 10 up to 70. So our first step is to find a symbolic representation of this function. So they want us to use f as the name of the function. So we have f of, and they want us to use x as our input. So f of x computes the cost of dollars. Let's see, the cost of driving a new car is about 50 cents per mile. So if we would drive 1 mile, it costs 50 cents. If we drive 2 miles, then it costs about $1. 3 miles, $1.50. So what we're doing is multiplying each mile by 0.5. So 0.5x, or you could also write 1/2 x. So that is our symbolic representation of the function. And let's represent this graphically. So here we have a graphing grid, and along the x-axis is going to be our x miles. So x is in miles, and the y-axis is going to be our cents per mile, or the cost. So let's put that, y is the cost. Now it helps if we write this as a fraction when we go to graph this. So if we write this rather as f of x equals 1/2 x, then we can recognize that this is the slope and the y-intercept is 0. So we'd have this point at the origin. This is just the first quadrant, the upper right-hand quadrant. So we have the point 0, 0, and then to get to the next point we go up 1, right 2 for the slope of 1 over 2. Up 1 over 2. Up 1 over 2. And so on. And then we connect that, of course, with our line. And let's make sure I've got that on there correctly. And put an arrow. It doesn't make sense to put an arrow here because in practicality we can't drive negative miles. Alright, so this is our graphic representation of the function. And then let's represent this numerically. Now numerically is a table. So numerically we make a table, and they've told us the values to put in the table: 10, 20, 30, 40, 50, 60, and 70 in that table. When I put a 10 in here, 1/2 times 10 is 5. So if you drive 10 miles, it costs you $5. 20, if I go 20 right there, 0.5 times 20 is a 10. In other words, all of our y's are going to be half of what those were. So 5, 10, 15, 20, 25, 30, 35. Right, you can see that a numeric representation is not a complete representation of that function, because we could drive maybe 12.8 miles, and that's not on the table. So you have to understand that the numeric representation of a function is not complete. It's going to be for specific values that you're told to put in, or something that makes sense in a presentation. Now we have something called the vertical line test that we use when we have graphs. If every vertical line intersects a graph at no more than one point, then the graph represents a function. So let's try this vertical line test on these. Let's determine whether the graph represents a function. If it does, then identify the domain and the range. Let me draw here a vertical line for you. Just take that line and draw it through your graph. Take your pencil and roll it across your graph. Does the line ever touch more than one point at a time? Doesn't ever there. So this passes your vertical line test. And does this pass the vertical line test? No. I mean, there's several places along here where we're hitting more than one point. So let's find the domain and the range for this one. The domain is, well, this is a line. It's going this way and this way forever. It's going to be covering all of our x's. So domain is from negative infinity to infinity. And the range, of course, this goes down forever and this goes up forever. So all of our y's are covered. So we have a range of negative infinity to infinity as well. Now I know that this does not represent a function, so we're not going to find the domain and range, but let's look at why the vertical line test actually works here. If you look here, we have touching at those points. That vertical line going through gives those 2 points. Those points are, well, let's say that they're probably 3, 2 and 3, negative 2. So you can see here we have one x, a 3, that has two different y's, 2 and negative 2. So that's the reason that that does not pass the vertical line test, and so that tells you why it's not a function. Let's see, would a vertical line test pass here? Yes. This is going to pass the vertical line test, so let's find the domain and the range. Now, when you're finding the domain, it's also helpful to roll your pencil across. If we rolled our pencil across with let's use a vertical line here, then let's see, what is the first x we come to? The first x we come to is a negative 4, and it keeps going. It's touching all these x's until we get here, which is a positive 4. So we have this domain of negative 4 to positive 4. And of course, those points are included. Now they don't have to be big bulbous dots for those to be included. Here they were kind of generous and let us have those nice bulbous dots to show that they are included points. But these are also all included points, and they're not bulbous dots, they're just part of the graph. Now if they do have an open point, you know for sure it's not included. So we have here from -4 to 4 on the x, and then if we wanted to do the same thing on our range, then we would draw a horizontal line up. So the first y value that we have is a 0, and it goes all the way up. We always have a graph until y is 4. So we'll have this range of 0 to 4. And of course, 0 is an included point. It's a solid point right there. And 4, those are solid points. Now this is not going to pass the vertical line test. You can see if we draw a vertical line through there, it's going to hit more than one spot. So this is not a function. It doesn't pass the vertical line test. If you're ever asked why a graph is not a function, you can just say it doesn't pass the vertical line test. Is this going to be a graph that passes the vertical line test? We pass the vertical line through here. It sure does. So we have a domain here of, let's see, negative infinity to infinity, because this goes forever. All of our x's are covered. And the range is going to be just 3. 3 is the only y that comes out of this function. So what we do is we have to use roster notation. It's not an interval of points, it's just a single value. Now does this pass the vertical line tests? It's a funny looking graph, but it still passes the vertical line test, so it is a function. Let's go ahead and find the domain and range. The domain goes from -4, we're covered until we get to +4. So -4 to 4, square brackets on those. And the range goes from -4 to +4. So -4 to +4 on the range as well. Is this going to pass the vertical line test? We can see right here it doesn't pass the vertical line test. We have, if we draw a vertical line through there, we have 2 points that vertical line is passing through. In other words, this is the point -2, -1. This is the point -2, 2. So we have an x of -2 going to 2 different y values. So this is not a function. Now, is this graph a function? Passes the vertical line test, so yeah, it's a function. Let's go ahead and find the domain and range for this one. Now, the domain isn't from -2 to 2. It doesn't include all the values between here and here, and between here and here, and between here and here. So we're not going to use interval notation. We're going to use roster notation where we simply list the values that are covered. So we have a -2, -1, 1, and 2. So -2, comma, -1, comma, 1, comma, 2. And the range is going to be -2, -1, and 1. Again, in roster notation, we only have 3 values where we have y's. Okay, so it's only -2, -1, and 1, not everything from -2 to 1. So we don't use the interval notation. So that covers this section. Go ahead and try your homework. Be sure and let me know if you have questions.